Now that we know that for such a impedance matching circuit, how the source impedance is transformed to the conjugate of the load impedance. That means by connecting a shunt capacitor, we are moving from that source impedance along the constant conductance curve to a point where the resistance is equal to 1 curve, and along the constant resistance R equal to 1 curve, due to this inductor, we are moving to the conjugate of the load impedance. Now let's see how to figure out this capacitor C and the necessary inductance L, the value of it, so that this movement in the Smith chart is possible. And for that we need to know the operating frequency, which is given as 2 gigahertz. So that movement in the Smith chart is a two-step process. So first let's look at the first step, where we are connecting a shunt capacitor and we are going to determine the value of the shunt capacitor. And since it is connected in shunt or in parallel, we are looking at the admittance value of the source impedance, which is 0.4 and minus j0.2. This can be directly read from the Smith chart by looking at the admittance curve, which is this curve over here, where it intersects at 0.4, and the constant susceptance curve, which is this curve here, which intersects at 0.2 on the rim of the Smith chart. So the 0.4 over here and 0.2, remember in the admittance chart, what we read is the negative of the susceptance. So this particular point is going to be 0.4 minus j0.2. We need to add such a shunt capacitor to move this point to this particular point, so that we end up at this point with a susceptance that can be read again from the Smith chart, and that turns out to be 0.4 plus j0.5. Remember, the starting conductance was still 0.4, the end point conductance is still 0.4, because we are moving along a constant conductance curve, and what really changes is only the susceptance, and it changes to a value of 0.5, which is basically this curve that we see here, that intersects the Smith chart at a point of 0.5. So how much is this difference to move this point from this source location to this intermediate point is what determines the value of that capacitor. So what we essentially need to know is the destination point minus the source point, what is the admittance, and that capacitance should be able to give you an admittance of 0.7, the difference between the destination minus the source. So once we know that is the necessary susceptance that we want to have, the normalized susceptance, then we can figure out the value of that particular capacitance from the theory of in an admittance chart. To realize this normalized susceptance, to recover back the capacitance, we need to denormalize it in terms of the characteristic impedance Z0, such that that denormalization procedure is given here to obtain back C2. And to do that, we need to know the operating frequency omega, which is basically 2 pi f. So to move from this source point to this intermediate point y1p, we would need to connect a capacitor in shunt, and the value of the capacitance is 7.4 picofarad. Now how do we figure out the amount of inductance that is needed, and from that the value of the inductor to move this intermediate point to the conjugate of the load? Then again the procedure is similar, but now since it is in series, we are looking at the series, we are looking at the impedance chart, we are looking at the final impedance, the ZL star that we want to hit, and the starting impedance value, which is Z1p. From Z1p we are going to ZL star. So from Z1p we are going to ZL star, so the difference in that impedance is going to be J1.02. Again, notice that the resistance at the starting and ending point is still 1, is the same. We are moving along a constant resistance curve of R equal to 1. So we would need the inductor here to provide a normalized inductance of 1.02. So from that we can figure out that the normalized inductance should be 1.02. So what would be the inductor that provides such a normalized inductance would be obtained as follows, where again omega is 2 pi f, where f is the operating frequency. So by doing this procedure, we can figure out what is the value of the shunt capacitor that is required and what is the value of the series inductor that is required to realize this particular matching circuit.